Class, in this video we begin the discussion in section 4.3 of your textbook on logarithmic functions. And so to begin, let's ask the following question. Okay, let's consider the exponential equation 2 to the y is equal to 5. Question is, what is the numerical value of y? Now there is no algebra that we can apply directly to this equation and solve for y. So let's we make some deductive we can do some deductive reasoning here. We know that 2 squared is equal to 4, and we know 2 cubed is equal to 8, and our equation is 2 to the y is equal to 5. Right? 5 is greater than 4 and less than 8. So using deductive reasoning, right, y must be greater than 2, the exponent y must be greater than 2 and less than 3. That's what we conclude here. Well, using our calculators and trial and error, right, plugging in numbers and checking, we can approximate y to be equal to 2.32. Just using our calculator and plugging in numbers. Right, 2 to the 2.32 power is equal to 4.993. So to denote the exact value of y, right, that equates 2 to the y is equal to 5, we have this fancy new notation. The exponent y up here, right, is equal to, using the base, right, the base of the exponential is 2, the value of the exponential is 5, using those two numbers 2 and 5, we can denote the value of y that equates to the y to 5 as log base 2 of 5. So log base 2 of 5 is our representation for the value of y that equates 2 to the 5 power to the number 5. So logarithms in a nutshell are a fancy way of expressing an exponent in an exponential equation. So let's let let's give a formal definition. A is a positive number not equal to 1. And so the logarithmic function with base a, denoted with this notation, is defined by the log base a of x is equal to y if and only if a, the base a raised to the y power, is equal to x. And so this if and only if means this goes both ways. If a to the y, or exponential a to the y, is equal to x, then it has to be true that exponent y is equal to log base a of x. So logarithms are just a fancy way of expressing the exponent y that equates a to the y to the number x. That's what we mean by these are equivalent equations. If the equation on the left is true, then the equation on the right is true. If the equation on the right is true, then the equation on the left is true. Okay? So, log base a of x is the exponent, right? Fancy way of expressing the exponent y, to which the base a must be raised to give the value x on the right-hand side. The base is the same in the logarithmic form and the exponential form, right? The base in the exponential form is a. The base in the logarithmic form is also a. Look at the diagram down here, right? The base of the exponential form is a. The base of the logarithmic form is a, right? So they both have the same base. And y on the right-hand side of the logarithmic form and the y in the exponent on the variable a, right? Y is the exponent in both forms. So let's demonstrate this with some examples. Right? The logarithmic and exponential forms are equivalent equations. If one is true, then the other must be true. So we know that 4 to the 0 is equal to 1. Right? 4 is the base of this exponential, 0 is the exponent. So in logarithmic form, the log base 4 of 1 has to equal 0, right? The base is 4 in both equations, and 0 is the exponent in both equations. We know that 4 to the first power is equal to 4, right? 4 is the base, 1's the exponent. So it has to be true that log base 4 of 4 is equal to 1. We also know that 4 squared is equal to 16. 4 is the base, 2 is the exponent. So the exponent 2 is equal to log base 4 of 16. 4 is the base in the exponential equation and in the logarithmic equation. Now let's go the other way. We have log base 3 of 27 is equal to 3. That, right, 3 is the base, 3 is the exponent. That's a true statement because 3 cubed is indeed equal to 27. Log base 3 of 1 is equal to 0. 3 is the base, 0 is the exponent. That's a true statement because 3 to the 0 is equal to 1. Log base 27 of 3 is equal to 1/3. That's true. 27 is the base, 1/3 is the exponent because 27 to the 1/3 power is equal to 3. Right? Remember, 1/3 as a rational exponent means cube root. Cube root of 27 is equal to 3. Log base 10 of 1/1000th is equal to -3. Right? 10 is the base, minus 3 is the exponent. That's true because 10 to the -3 power is equal to 0.001. And now we got one involving a couple involving variables. Log base 7 of 3 is equal to x. Right, 7 is the base, x is the exponent. So if this is a true statement, then 7 to the x power has to equal 3. And then we have log base 7 of 3y is equal to 5. If this 7 is the base, 5 is the exponent. If this is a true statement, then it must be true that 7 to the 5th power is equal to 3y. All right, and then let's do some more from exponential form to logarithmic form, right? We know 3 squared is equal to 9. 3 is the base, 2 is the exponent. So the exponent 2 has to equal log base 3 of 9. 2 to the 5th is equal to 32. That's a true statement. 2's the base, 5 is the exponent. So it must be true that log base 2 of 32 is equal to 5. 4 cubes equals 64. That's a true statement. 4 is the base, 3 is the exponent. So it must be true that log base 4 of 64 is equal to the exponent 3. And then 3 to the 5x is equal to 10. If that's right, 3 is the base, 5x is the exponent. If that's a true statement, then it has to be true that log base 3 of 10 is equal to 5x.